So we're talking about the product rule of derivatives. So we're given this g of t, and we have this function here, and we're going to find g prime of t. It says to do this on a scratch sheet of paper. We're not going to do this. What we're going to do is we're going to do this, and then I want you to do it right here. Okay? And you do that while I figure out where I left my drink. So what I've noticed from, I think all of you, but maybe not, is that you started by multiplying these two together. So why did you feel like you needed to multiply them together before you took the derivative? There's not a wrong answer. It would be easier, the powers. Do you know what to do when things are being multiplied? No, that's probably another reason, right? So what if I had f of x equals 5 times h of t, right? Those two things are being multiplied, right? But the derivative would just be 5 times h prime of t, right? That makes sense? We know that, right? But 5 is just a constant. It's not another function, right? And I have two functions here that are being multiplied together. So what normally happens when we do this is that, and so I want you to write this somewhere. Don't erase anything you have. But if you didn't have this, what we get a lot here is g prime of t. So again, write it, but don't erase what you have. Equals, and then if we take the derivative here, this would be 6t plus 1 times 2, right? Is that what that would be? If I just took the derivative of inside of each other? You agree with that? Okay. Which would equal to 12t plus 2. Is that what y'all got as your answer? And I'm not saying you're right or wrong, but it's not what you got, right? And I told you not to erase it. All right, so instead, if we do what you did and we say, all right, I'm going to rewrite it first, g of x, and so if we multiply, we're going to get 6t cubed, is that correct? And then minus 15t squared plus 2t squared. Oh, I guess I could have put those together, but I didn't. Plus 2t squared minus 5t. Right, and then so that means g of x, I'm still with g of x, is equal to 6t cubed minus 13t squared minus 5t, right? So if you multiplied it out, that's what you got, for g, rather. And then from here, you took the derivative, right? So then g prime of x would give you 18t squared minus 26t minus 5. Okay? So without any direction from me, because I didn't tell you what to do and how to do it, you doing either thing would make sense to me at this point, okay? Because you don't know exactly what to do. So if you tried to just do this, but if you thought that would be easier, this is actually the correct answer, okay? Because this is different than this, even though there's multiplication here, because we're not multiplying two functions, we're multiplying a function and a constant. When you're multiplying two functions, then things have to change, okay? So you have this, and I told you to write it down. We're not going to scribble out anything, just put an X through it, just so we know that. And if that's what you had at first, just have the correct one there as well. All right. So it says we all know one thing that is nice about math, at least pure math, is while they're hard, the solutions are rigorous, but they have a checkable answer. We can't possibly get different answers for problems for most of them. So which one do you think is the right answer? We already said we know which one's the right answer, and so we can just draw now. That one, you can draw an arrow to wherever yours is. So, do you think we can always use this technique, that we can always just multiply it out? These are two polynomials, right? Is everything we ever do a polynomial? No, because like we can have trig stuff, we can have all sorts of stuff, right? So we cannot always rely on this. The answer is no. Everything isn't a polynomial. Plus, not only that, but we don't even have to necessarily multiply it out when it is a polynomial. I have a different way to do it. So there's a rule. Whether they're polynomials or not, I have two functions that are being multiplied together, not a constant and a function. So here's what I don't want you to do. Although it would work, it would just be steps you don't need to do. I don't want you to take something like this and start applying the rule we're about to do, just because there's multiplication. Because this is called the product rule. Product means multiply, right? But that's when we have the product of two functions, not a function and a constant. Okay, so don't change. You already know what to do with that. Don't make that any more difficult than it needs to be. So your product rule looks like this. So we talk about these as this is the first function, this is the second one. Okay? So we take the derivative of the first, g prime of x, times the second, h of x, plus the first, which is g of x, times the derivative of the second, h prime of x. And we're going to do this so much, you're going to know that pattern just fine. The derivative of the first times the second, plus the first times the derivative of the second. Okay? Works every time. So let's go back up here, and let's basically do that with this right here. Okay? We use this right here. So g prime of x. So here are two things. This is 1, this is 2. So the derivative of the first, which is 6t plus 1, right, times the second, which is 2t minus 5. Y'all agree with that? Plus the first, which is 3t squared plus t times the derivative of the second, which is just 2. And that's going to get me the same answer. Okay? And I could, if I'm just taking the derivative, I could stop here. If I need to substitute something in, I could stop here. I don't have to simplify it or anything. Okay? So let's work this out so we can see that we actually get the same thing. So I'll move it so you can see it. So if I multiply these out, I'm going to get 12t squared, and then I'd have negative 30t plus 2t, so that's negative 28t, and then minus 5, and then plus 6t squared plus 2t, which gives me 18t squared minus 26t minus 5. I hope that's what we got up there. Oh, look at that. Okay with that? And again, depending on what you're doing, you may or may not even have to do this step. You probably stop here, and sometimes, like if I wanted g prime of 1, I can just plug it in here. I don't have to do all the algebra to get me down there. No, that's necessary. Plus, they're not always all algebra, right? So let's look at this. So important notes. In calculus, we only take one derivative at a time, which means I'm not taking the derivative of g times the derivative of h. Every time, whether we're doing the product rule, the quotient rule, some other rules, it is just one derivative at a time. So, and then it says another way we can express the product rule in terms of u and v, and so u and v are going to become very important to us. So uv prime, this is going to be, again, the derivative of the first times the second plus the first times the derivative of the second. Okay, and we'll talk a little bit more about u and v when we do one of the other rules. All right, so let's try f prime of x here. Our rule is the derivative of the first. So what is the derivative of x squared? 2x. So that's the derivative of the first times the second, which is sine of x, and then plus the first, which is x squared, times the derivative of the second, which is cosine x. And you're done. That's it. You want to try the next one? Try the g of x. Just say the pattern to yourself over and over again. Derivative of the first times the second. Do you agree with that much right there? Okay. Everybody at least get that first step? Okay. So yes, this is a safe stop. And if I needed to substitute in, I could here. But we're going to simplify 2 more times. Okay? And I'll tell you why as we do this. So this is also g prime of x would equal 3x squared times the natural log of x plus x squared. You agree with that? Okay. And if you were simplifying it, you wouldn't necessarily need to go to the next step. Well, depending, maybe if this was in the numerator of something and I have something else in the denominator, there may be other reasons. Or if this isn't a multiple choice question and neither one of these are answer choices, you've got to be able to figure out if you actually have what matches one of the answer choices. So wouldn't this also be x squared times 3 times the natural log of x plus 1? Is that the same thing? I just factored out a GCF. Okay? So at least, you should be capable of doing that, and you should be able to understand that that would be the same thing. Because look, if I multiplied this back, I see some squinty eyes. If I multiplied this back in, then it would give me this back right here. I just factored out a GCF is all I did. Okay? Because you never know what the form of the multiple choice answer could be. We okay with that? What questions you got? All right. Now let's look at F. And we're going to kind of examine this before we jump in and start doing things. Because I have a polynomial here. Well, it's not a polynomial, I'm sorry. I have 2 terms. So I have this term and this term right here, right? And they're separated by a minus sign. These 2 things that I just underlined not being multiplied, right? However, this one, I do have this and this being multiplied. Does that make sense to you? You've got some options here how you handle the negative sign. You can either attach it to the 2, or you can leave it as minus in there, but if you do that, you have to make sure that you have parentheses and you distribute things, and you can get lost in that sometimes. So I would treat that as negative 2 e to the x when we do it. Does that make sense to you? It's just going to be a little bit easier if you just attach that negative there. Okay. So, but when I do that, this is going to take the product rule. That doesn't affect my x at all. I still just do him separately like I would anything else. All right, so f prime of x. So what's the derivative of x? 1, right? It's just 1. So then I'm going to do my product rule here. The derivative of the first, so that's negative 2 e to the x. What's the derivative of that? What's the derivative of e to the x? E to the x. So it's still just negative 2 e to the x. So the derivative of the first times the second, which is the cosine of x, right? Plus the second, plus the first, which is negative 2 e to the x. What's the derivative of cosine? Negative sign. So I'm going to put sine, and it should be a negative sign. So that negative is going to cancel that negative out and make the whole thing positive there. Does that make sense? You can put it in parentheses if you want and then simplify it. But I had the negative 2 because of that, and then it was a negative sign, so then my negative 2 became a positive 2. We okay with that? Now, could I factor a little bit here? Yes. Do you have to? No. Could you see something on a multiple choice test? Yes. So let's look at what you might see. F prime of x equals. Now I can't factor out of the whole thing because I got this 1 here, right? But I have this 1. I can factor out a negative 2 e to the x. And if I do that, that leaves me with cosine of x minus the sine of x. Which may or may not help me depending on what's happening, right? Or if it's multiple choice. But if I was just evaluating, I could have stopped here and done that. Any questions about where anything came from? Yes, sir. Mm-hmm. Well, I did. I had plus a negative 2 e to the x times, and then this was a negative sign, so the negative sign made that positive right there. Oh, because I already took this derivative. I took this derivative, that's this guy right here. The derivative of this is all of this right here. Because it's my product rule. No, this is like Q minus U times B. This is like its own little thing. Like I did this term, and then I did this term, and this term takes the product rule. So this whole thing comes from there. Does that make sense? I don't put it again. I see what you're saying. Yeah, that X has nothing to do with my product rule. He's just hanging out right there. I just use him separately. Okay, we good on that then? Very good question. What else you got? Anything else? Okay. Should I do anything before I start this one? Maybe rewrite something? Square root of X, yeah. So h of X, I'm just rewriting, is equal to the cosine of X times X to the 1/2 power. Okay, so then h prime of X equals. And I don't have any other terms, right? It's just all one big term. So the first thing, I take the derivative of the first. What's the derivative of cosine? Negative sine. So negative sine of X times the second. So I can leave it as X to the 1/2, or I can put the square root of X. I'm going to just put it back as the square root of X, because a lot of times we're doing this so we can then evaluate, and we'd want it back in the root form, okay? And then plus the first, which is the cosine of X, times the derivative of the second. So that's going to be 1/2, right? So because I'm going to multiply the 1/2. Then what does the exponent become on this? Negative 1/2, so it's really just the square root of X in the denominator. And then you could write it as cosine over all of that. That's fine too. But we don't need to do anything else with this. Can I factor out a square root of X? No, because one's in the numerator and one's not. Okay. Any questions about that one? Speak up if I have lost you anywhere or you're questioning anything that's happened. Okay. Good deal. So let's flip it over then. All right, so we got selected values of the twice differentiable. That means I can take the derivative twice, are given by the table. And if it's differentiable, what does that mean also? Continuous, right? You don't even know why that's important yet, but we're going to start writing it so we know it. We know it when we get there. Differentiable means that it's definitely continuous. I did not mean to mark that out, though. Whoop, there we go. Are given in the table above, along with f prime of X and f double prime. Use this information to find the following. All right, so before we find f or h prime of 1, I have to find h prime, right? So I have a 4, which is just a constant, and I'm just going to stick that 4 to the x. So that 4x is like my first. When we talk about the first and the second, it's like my u. And then f of x is like my second, right? So then that means that h prime of x is equal to the derivative of the first. What's the derivative of that? 4 times the second, f of x, plus the first, which is 4x, times the derivative of the second, which is f prime of x. So then I want h prime of 1. That's going to be 4 times f of 1 plus 4 times 1 times f prime of 1. Just substitute it in, right? Zero work there. So now I'll go find my stuff. What's f of 1? 6. So this is 4 times 6 plus, then that's going to be 4 times what's f prime of 1? Negative 2. So that's going to give me 24 minus 8, which is 16. Any questions about that? All right, you find the derivative of k. Find k prime, and we'll make sure we agree before we move on. Still agree with K prime? If you're not done, I'm sorry if I went fast. So I got 3 cosine of x times f of x plus 3 sine of x times f prime of x. We all good with that? All right, so then go ahead and try and get your K prime of 0 done. Bless you. Bless you. They're like little puzzles, right? And in your head, every time, I want you to say to yourself, the derivative of the first times the second plus the first times the derivative of the second. Like, repeat that over and over and over again. Any questions about where anything came from? So cosine of 0 is 1, and the sine of 0 is 0. Yes? Got to know your trig values. This is the one where we got tripped up the other day, right? It was cosine of 1, and then I had like my brain like fizzled out for a minute. I was like, we should know that. No, we shouldn't. And yeah. We all good now? Okay, beautiful. Now, let's look at P, and let's think before we start here. I have 2 big terms here, right? I'm going to have to do the product rule twice, and they're unrelated to each other. Here, in this first one, I've got these 2 terms. And then here in this one, I've got these 2 terms. And again, I would highly suggest to make your negative sign life a little bit easier, just attach that negative to whatever that first term is, to the f prime, okay? So I want you to do p prime on your own, and then just stop. Don't go to the p prime of 5. Let's make sure we all agree. Try to think through it on your own, and then we'll double check, and I'll answer any questions we got. What did I do wrong? Did I do something wrong? Oh, it doesn't look good. You're right. It looks horrific. Yes and no. Okay. Oh, I see what you're saying. So here, this is the second, right? So it's derivative of the first times the second, and then the first, and then I'm just doing the derivative of what's in there, and then yes, I did those like separately. Yes, like you already know how to do. Yes. Okay. And you could have put a minus here, but I was doing the rule of plus the derivative, the first times whatever. So it could be minus there too. That's fine. Now, could we clean this up and factor? Yes, we absolutely don't need to. We are trying to evaluate. So, but any questions about how we got here first? And if you're still working on it, I'll give you a second. It's fine. I'm not trying to rush you. I'm just answering some questions already. But do you see how I did like in this bright blue and this purpley blue, this whole thing was just this product rule, and this whole thing is just this product rule. Two completely separate things. Ask me a question. Yes. They're completely unrelated to each other. They just happen to be in the same equation. Okay? You okay with that? Are we good to move on to P prime of 5? All right, find your P prime of 5. Yes, plug it in. And you may have to go down the side a little bit or something because there's not a ton of room. I heard that. I can't even see the chart. F I know. Sorry that there's not enough room to write. F double prime plus 2 minus F prime of 5 is 7 times 2. So here's some good news at least. Bless you. This is a safe stop right here. You wouldn't have to go any farther. Should we be able to? Yes. We may need to, but that is a safe stop. This is not, because we still have F and stuff in there. Once you substitute it in, you're fine. But look, this is 3e to the 5th plus 7e to the 5th. What is that going to give me? 10e to the 5th, right? And then this is going to give me negative 40 and negative what? 63, so that's minus 103. That's your actual answer. Okay. Ask me a question. Oh, I was just using that as a multiplication. Like I could have put a little multiplication sign. Oh, because it's minus. Yeah, because because I was connecting. Oh, yeah. Okay, let me give you a minute to let all that sink in. Are we all good? This is 3e to the 5th, 7e to the 5th. So that's 10e to the 5th. And then this is negative 40 and negative 63, which is negative 103. What's that? You could have put in another step if you needed to. It's fine. What questions do you have? We're all good? All right, let's move on to the next one. And you always want to read, I know it's shocking, but you want to actually read the things that are written there for you. So we have the graph of g of x. It's important to know if we have g or g prime or g double prime. And it says linear pieces and semicircles. So they're not like parabolas or anything. They're circles, which means we know things about the radius and whatnot. Use the graph to answer the following. Okay, so we want this to be like x to the 1/2 power, right? So we're going to do p prime of x. The derivative of the first, g prime of x, times the second, which I'll go ahead and just put, because I'm going to evaluate, I definitely want it as a square root, right? Plus the first, which is g of x, times the derivative, which is going to be 1 over 2 times the square root of x. Do you all agree with that? And I don't need to clean it up any because I can just clean it up kind of as I evaluate it. So I want p prime of 9. So this is going to be g prime of 9 times the square root of 9 plus g of 9 times 1 over 2 times the square root of 9. And there is not nearly enough room to write on all this stuff. Sorry. Y'all probably might have more room on your paper, maybe not. Maybe we write around the side. I don't know where to write this. But all right, so what is g prime of 9? I think I'll come up here. Here's 9, right? So is g prime 2? The slope happens to be the same, right? The slope's positive, right? I go up 2 and over 1, so it happens to be the same. Coincidence, but it works, right? So I'm coming back up here just so I have room to write. P prime of 9, so this is going to be 2 times the square root of 9, which is 3, good job, plus, what is g of 9? 2 times 1 over what? 6. So I have 6 plus 2 times 1 over 6. So this is 6 plus what? 1/3. And as an improper fraction, what is 6 plus 1? We're not cooking. So since I could make it 6 1/3, but we're not cooking, I don't necessarily have to think I have to get a common denominator. Think about it as 6 1/3, and what would it be as an improper fraction? It'd be 19 over 3, right? There's another way to look at that. 19 over 3. Can't be afraid of fractions, guys. All right. Yes. Even actually, so yes, this is a safe stop, and this actually is a safe stop. This is not, because we haven't actually substituted our values in, but even this is a safe stop, 100%, yes. But again, we can't, if we always safe stop when we're working through things before we get to the test, we're never going to remember how to actually do things to get there. All right, I want y'all to, we're going to do this one last one. We will stop here today. I will give you your assignment if you want to work on it, but what we're going to do tomorrow is we're going to do these last couple together, and then you're going to have time to work on your assignment. So I'll just give it to you in case you're not here, or if you want to get started on it, whatever. But I'm going to pass those out while you do H. Let's make sure that we at least can. Because this is a skill you're literally going to be using all year long. So we got to make sure we can practice on this. And you'll get better and better at it. I have my H prime. If you want to check your H prime before you do H prime of 5. Of course, if you don't agree with me, doesn't always mean you're the wrong one. Y'all know that well enough by now. Oh, shit. Oh my gosh. There we go. So G of 5, I think is 1. I agree with that. Plus 25 times. What's G prime of 5? Undefined. Why? Vertical asymptote. Good. It's not a sharp turn, but it is a vertical asymptote. So but this is important, guys. You can't put plus times undefined. So at this point, you can just kind of mark it out and just say this is undefined. Okay? Don't ever put equals undefined. That's bad, real bad. Okay? All right, we all good? So we will work through those last two tomorrow, or I may have you kind of work them, and then we'll talk about some things, but especially some notation on that last one. Oh, and I lost my stop button again, because I don't know, where did he go? Oh, there it is.